You probably recognize this picture from high school. The atom as a tiny solar system, with electrons orbiting a dense nucleus on perfectly clean tracks. It's a design used for the logos of 1,000 science-y companies. But that intuitive image is a lie. It is a convenient fiction that masks a much deeper, stranger truth about the nature of matter. This model began with Ernest Rutherford, proving atoms had a dense center, which Niels Bohr then refined by placing electrons onto these neat, distinct circular paths. The problem is that 19th century physics is very clear about charged particles. Anytime they accelerate, they must emit electromagnetic radiation. Think of it as a constant energy tax. Because an electron is negatively charged, and because moving in a circle requires a constant change in direction, which is acceleration, a planetary electron would be in a permanent state of energy loss. As the electron bleeds energy, its orbit becomes unstable. It would lose speed and immediately begin a death spiral directly into the positive nucleus. This collapse is nearly instantaneous. Calculations show the entire decay would happen in roughly 10 picoseconds, 1/100th of a billionth of a second. Under the laws of classical physics, every piece of matter in the universe should have imploded the moment it formed. The fact that your chair is currently holding you up proves that classical physics is broken. Physics was broken. The universe needed a hero. The study of light revealed the first evidence that the classical view was wrong, centered on an arrangement called the double-slit experiment. In our macro world, firing solid pellets through two slits creates two distinct lines on a backscreen. It's exactly what you'd expect from solid objects. But ripples in water behave differently. They pass through both slits, overlap, and interfere with each other, creating a complex pattern of many lines on the screen. When physicists fired electrons one by one, they didn't get two lines. They saw the electrons build up that same complex wave pattern, as if each individual electron was traveling through both slits at once. When they placed a detector to watch which slit the electron actually used, the behavior changed. The moment the electron was observed, it went back to acting like a solid pellet, and the wave pattern vanished. This experiment proved the electron exists as a ghostly wave of possibilities, shattering the idea of the electron as a tiny, solid planet on a fixed track. To resolve the collapse paradox, we have to stop thinking about orbits and start thinking about standing waves. A guitar string is fixed at both ends, meaning it can only vibrate in specific, stable patterns called harmonics. Any wave that doesn't fit the length of the string perfectly will simply cancel itself out. In an atom, the electron's wave is tied down by the electrical pull of the nucleus. Only certain circular paths allow the electron's wave to fit around the center without destroying itself. These stable patterns are called atomic orbitals. They represent the only energy states where an electron is permitted to exist. This solves the doomsday scenario. In its most stable state, the electron is simply in the lowest possible wave pattern. Because there is no lower note for it to play, it cannot spiral into the nucleus. It is perfectly stable. Modern electron cloud diagrams are actually a probability map. They show us where the electron is most likely to be found if we were to look for it. Until we make that measurement, the electron doesn't have a specific location. It exists as that entire cloud of potential all at once. This leads to a rule defined by Werner Heisenberg, the uncertainty principle. It is physically impossible to know both the precise position and the precise momentum of a particle at the same time. This principle acts as a quantum pressure. If you try to pin the electron down into the tiny space of the nucleus, its momentum becomes violently uncertain, kicking it outward and preventing the atom from crushing itself. This quantum architecture defines every physical interaction in the macro world. Chemical bonds and the shapes of molecules are determined entirely by how these probability clouds overlap and settle into stable patterns. Solid objects feel solid because the massive electron clouds in your hand are electrically repelled by the electron clouds in the objects you touch. There is also a rule called the Pauli exclusion principle, which forbids two electrons from occupying the exact same quantum state in the same place. Pushing your hand against a wall feels like hitting a solid surface, but it is actually the pushback of quantum probability laws. The predictable, solid world is an illusion built on a shimmering ocean of quantum excitations. Subscribe and hit the bell to continue exploring the impossible reality beneath our feet.